Let's consider our triangle ABC. Let me minimize it. It is A, it is B, it is C. And let's label them A, B, C. So that it says B is inside BAC is equal to ACB. BDC is 90 plus A. So D, for example, is a point like this, BDC. Okay, this DAC, this angle is C. And this angle inside is 90 plus A. Point E is chosen on ray. It is so that AE is equal to EC. So because A is equal to EC, it lies on perpendicular bisectors. So if we consider AC, 194 is around, for example, this one. And for example, this is this. Okay, we extend something like this and draw perpendicular bisector like this one. And this point is E, so it is equal to this one. If we connect, AE is equal to EC. Let's just show that M is midpoint of BC. So let's gonna consider BC is 170, 85. This one is M. Show that line AB is tangent to the circumcircle of triangle BEM. BEM. Okay, and let's extend this. So if you want to prove that this line is tangent to the circumcircle of triangle BM, we should prove what?
The circumcircle of BDM or BEM.
It's a circumcircle of BEM. Okay, so let me write BEM. Okay, so it's equivalent to what? For proving this, we should do what?
I know it should be one of the angles, but I don't know.
We should prove which angles are equal.
I'm not sure.
So let's consider. For example, suppose we have a triangle and we have a circum. Okay. Now this line is tangent, so which angle is what?
BEM is. Wait, what is your question?
I said now here is tangent. Which two angles are equal?
A and BC. It's not labeled BC like.
But now let me call it X, this one Y.
It's.
Then this line is tangent. Which two angles are equal?
Is A and BC X?
What angle should be equal to what angle?
A and BC X?
Exactly. This one is A, and this one is what?
B?
Yeah, sometimes it's easier to prove this, sometimes it's not. So now that we know this point here, we should prove which two angles. Let me call this one X. We should prove which two angles are equal.
We should prove MBX and E are equal.
MBX should be equal to what?
Oh wait, MBX and M. Like MBX and then angle BME. Oh no, opposite, right? So opposite would just be BEM.
Yes, BEM. Or which two angles?
Or angle ABE equals angle BME.
BME, yes. BME should be equal to what?
BME equals to ABE.
AB. Okay, ABE, we don't know ABE is what. What we know BEM is what in terms, sorry, MBX is what in terms of ABC. It's what in terms of ABC.
Which angle? Sorry, I can't hear.
MBX is equal to what in terms of ABC?
A plus C.
Uh,
Angle
MBX is equal to what in terms of, yes, ABC.
A plus C.
MBX is what in terms of ABC?
Did I say A plus C? A
Yes,
plus
or
C.
yes, 180 minus BS or A plus.
Yeah.
So, because we know this angle, let's focus on this, okay? Because
Okay.
here we don't know BME, we don't know ABE, we don't know any of them. But here, at least we know this. So let's focus on this. If we prove BEM is equal to 180 minus B, the problem will be solved, right?
Mm-hmm.
Okay, here, because we have perpendicular bisector, when I told you perpendicular bisector, let's call it N. It is related to what?
The circumcircle.
Exactly. So let's draw circumcircle. This one. Okay, and we have some conditions about the angles. Let's use some angle chasing. So we know that this angle is C, right? So let's extend the line to conclude, for example, something on the circle. It is C, so we can extend it. So we can say this arc is what? Arc FC
And this arc is.
in terms of ABC.
Oh, it's just. Isn't it just C based on the definition?
It says C in the definition of the problem. It says FAC is C.
Okay, and yeah. So FAC is just C from the problem statement, or just from
Yes. So it is. So the question mark is what?
2C.
Exactly. It's 2C. So
Okay.
what's arc BF equal to in terms of ABC?
Well, it would be 2A minus 2C.
Yes, 2A minus 2C. This one is 2B, this one is 2C, right?
Yeah.
Okay, so what's this angle? Let's use angle chasing. What's this angle equal to?
A minus C.
Exactly. Let's maximize. This one is A minus C. Minus C. Okay. Now let's connect, for example, these points because we found these arcs, so we can find the angles.
Mm-hmm.
So let's write each angle. This angle is what?
This angle is like CBF.
Yes, CBF is in terms of ABC.
Just C.
Exactly, because half of this arc. What's this angle equal to?
A minus C.
Exactly. Now by considering these angles, we can prove two lines are in this figure are parallel to each other. Try.
I'm not sure which two lines are parallel.
Okay, so what's this angle equal to in terms of ABC?
It's just A, right?
Exactly. A. Because it is B, it is C, B plus C plus A is 180. So this angle is A. Because this angle is A, you can prove the two lines that are parallel to each other.
Mm-hmm.
Which two lines are parallel?
Oh, I still don't see it, just based on this.
Okay, because look, when we have two lines like this, and we have a parallel line with these two parallel lines, and this line intersect, these two angles are equal, right?
Yeah.
Okay, so this is the, like these two angles, this is the first A. This is the second A. So because these two angles are equal, then which two lines are parallel to each other?
A, wait, which two angles are equal, you're saying?
A, we have two A's. This is A, this one is also A, right?
Mm-hmm.
So we can conclude which two lines are parallel to each other.
Wait, can you say again? I can't really hear. What angle you're saying is equal?
Look, A, let me show it with green. This angle is A, agreed.
Yeah.
This angle is also A. Can you see the two angles that I marked them?
Mm-hmm.
Okay, so use this approach that these two are parallel to each other when these two angles are equal. Use the same thing and conclude which two lines are parallel.
So then just AC and BF.
AC and BF, good job. AC and BF are parallel to each other. Remove it. Okay, these two are parallel to each other. Okay, because these two are parallel to each other and this one is 90. If we, let's extend this. If we extend this one, the figure is not so much good. If we extend this one, okay, so suppose this is an outline. Let me maximize it. Okay, this is a line. Okay, in this figure, we can conclude what's this angle equal to?
90 degrees.
Exactly. These two are parallel. This is 90. So this one is also 90. And let's call it L, okay? Then prove that
Mm-hmm.
BL is equal to LF, okay? Try to prove it. L is the midpoint of BF. Try.
But we know N is the midpoint of AC, right?
Yes.
Okay. And BAF is equal to BCF.
BAF is equal to BCF, yes.
Okay. How do I approach this part?
Okay, so what can we say about this quadrilateral ABFC?
Cyclic.
A cyclic, yes. What else?
It's a trapezoid.
Is a trapezoid? Yes. What trapezoid?
Well, it should be an isosceles trapezoid.
Exactly. Why it's isosceles
And,
trapezoid?
well, BAF is equal to BCF.
Yes, or AB is 2C this arc, this 2C this. In general, when we have a cyclic trapezoid, it is isosceles because these two arcs are equal, right? Because this angle is equal to this angle, then these two arcs are equal. So these two chords are equal, right?
Mm-hmm.
Okay. Now you can use, by using the equality of these two lengths, that ABFC is an isosceles trapezoid. we can prove BL is equal to LF. Do you need another hint, or is that enough?
Wait, why is it not enough to say that since Ln is already the midpoint of AC as an isosceles trapezoid, is that not enough to prove that
Yes, you should
L
say
is
this
the midpoint
because
of BL?
if by symmetry you can say because it is perpendicular bisector of AC, it passes through this, right? Or you
Yeah.
can say because it is perpendicular bisector of this, it passes through O, right?
Yeah.
For example, O here, some point here, if you consider. And because again, perpendicular bisector of this also passes through O, because these two are parallel to each other, their perpendicular bisectors are parallel and they intersect in O, so it should be the same line, right?
Yeah.
Okay, so we proved BL is equal to LF. Now we can say, let me show it with the red. This length is equal to this length, and we know BM123 is equal to MC, right?
Mm-hmm.
So we can conclude, for example, LM is parallel to what?
Lm parallel to Fc.
LM is parallel to FC, exactly, because midpoint, by Thales' theorem or Thales' theorem, we can say LM is parallel to FC, right? So we are using angle
Mm-hmm.
chasing, parallel lines, all these things, and also if you can find cyclic quadrilaterals, then we can conclude some more angle chasings. So here, we worked a bit on for example, on the assumptions of the problem. Now let's focus on this. We want to prove BEM is 180 minus B, right? This is
Mm-hmm.
BEM. What's this angle equal to in terms of ABC?
Just B.
Yes, good job, it's B. And so if you want to prove 180 minus B and B, these two angles are good because their sum is 180, and for cyclic quadrilaterals we can use it, right?
Mm-hmm.
Okay, but here we know, okay, this is F, and for example, this point 180 minus B. So how can we create cyclic quadrilaterals? Let's extend, because 180 minus B we have. Here, if we extend this, let me like the square one. Okay. If we extend this, so we know that we should prove this angle is equal to what?
Well, if you extend that angle is equal to 180 minus BEM,
Yes, and we
and
want to
then
prove BM is 180 minus B.
yeah, so we want to prove that that NEM is B.
NEM, this one is B, not N, because extension of this intersection, for example,
Yeah,
let's
yeah, yeah.
call it for
Midpoint.
example, K, or we have LT. We should prove TEM is B, right?
Mm-hmm.
Okay, it is B, it is B. Now here, because it is 180 minus B, we want to prove. For example, one way is to extend this, and we should prove this one is cyclic quadrilateral, right?
Yeah.
Or one way, for example, because we extended this, we know it is midpoint, right?
Mm-hmm.
So if you consider, for example, E is midpoint of what? For example, B is equal to, for example, E prime. Then, like this one, we call it midpoint theorem, that LM is parallel to FC. Do you agree we can say C prime is parallel to EM if E is midpoint? Suppose BE is equal to EE
C
prime.
prime.
C prime. Do you agree
Okay.
will be parallel
E.
to EM if this length is equal to this length? Because M is also midpoint, then by Thales' theorem or Thales' theorem, we can say these two lines are parallel to each other, right?
Yeah. EM and E prime C. Yeah.
Yes. Okay, so now here, I said we should extend this one to create a cyclic quadrilateral, or this one. Then we know that, for example, let's call this angle alpha. We want to prove alpha is 180 minus b. We know this angle is what in terms of alpha?
Which angle?
The question mark.
BEC.
In terms of alpha. BM, I consider BM is
well,
alpha.
if they were parallel, it would just be alpha.
Exactly. So we should prove that, see, this alpha is 180 minus b. So it is 180 minus b, this is b. So it's equivalent that which quadrilateral is cyclic?
FD prime C.
FD primes. So if we prove this one is cyclic, the problem will be solved, right?
Yeah.
Okay, so here can we conclude any good thing? For example, let's connect E prime and F. Because they are midpoints, we can conclude some good thing. This is midpoint. Do you agree FE prime is parallel to what? Again, you should use the same thing. The same approach to find FE prime is parallel to what?
Okay, well, I guess by the same thing, it's parallel to LE.
FE prime is parallel to, yes, exactly, because it is midpoint and this one also is midpoint, so it's parallel to LD, right?
Yeah.
Okay, so because these two, so let me write with red. So this line is parallel to this line. So what's this angle equal to?
This angle is 90 degrees.
Yes, good. 90 degrees. So because this angle is 90 degrees, you can find this angle. Understand? Let me tell you which angle. DFM is what in terms of ABC? Okay, let me see. Can we calculate it in terms of ABC or not? We have 90. Yes, we can calculate it. Calculate DFM in terms of ABC.
DFM, okay. 90 minus C.
90 minus C, yes, good job. Because this one is C, so this one is 90 minus C. So let me write it here. 90 minus C. Okay, we want to prove FDE prime C is cyclic, right?
Yeah.
Okay, so if we prove D1 is equal to, or let me tell you, it's equivalent to prove angle E prime DC is equal to which angle?
We won't prove E prime DC is the same as E prime FC.
Exactly, and it's not hard to prove. Try to prove these two angles are equal, then the problem works.
I'm not sure how to prove this part. I feel like I'm missing something.
Okay, so let's prove it. ED prime C is what in terms of ABC?
ED prime?
Sorry, E prime
E prime
DC.
D.
E prime DC is what in terms of ABC?
In terms of ABC.
E prime DC.
Oh, wait, it's 90 minus A. Oh.
Yes, so it's 90 minus A. So we should prove E prime FC is 90 minus A. Want to prove it on your own or do you need a hint?
No, yeah, I'll keep trying. Can you explain?
Okay, sure. This is 90, this is 90, this is 90. So what's this angle equal to?
Wait, which angle? I can't see.
This one. Let me call this, for example, this point as P APF.
APF?
Yes, APF. APF is one.
I'm not really sure how to write in terms of
Okay, so
ABC.
look, this is not in this quadrilateral, NPFL. NPFL. If you consider 3 of the angles are 90. N is 90, L is 90, F is 90, right?
Yeah.
So what's the fourth angle equal to? In a quadrilateral, if 3 of the angles are equal to 90, what's the fourth angle equal to?
The first one is just 90.
90. Or you can say we know these two lines are parallel, BFAC, right? And also these two lines are parallel, we proved. So it's a parallelogram, so it's 90, this one is 90, right?
Yeah.
Okay, so this is 90 degrees. And what's this angle equal to? Let me determine. ACF. What's ACF equal to? In terms of ABC.
This is just A.
It's what?
A.
Yes, good job. Because A minus C plus C is A, right? So this angle is equal to A. So if EF, then we found this is 90, this one is A. So what's E prime FC equal to? This angle. Do you need a hint?
Yeah.
Look, this is 90. This is A. So in this triangle, one angle is 90, one angle is A. So what's the third angle?
90 minus A.
Finished. So these are 90 minus A. So we prove this cyclic and this, right?